This is 6.4 Player Evaluation and Feedback for Future Actions by Upton. Firstly, I'm going to talk about the group data and use Pearson's correlation test to see if there is a positive or negative correlation between the different components, and also to see if the graph has significance or doesn't have a significance. I can tell this by looking at the P and R value. Figure 1 shows how height affects 2 pointers made. From this graph, I can see that there is a negative correlation as the R value is a minus. This is shown for the straight line. This graph shows how height doesn't affect 2 pointers made. The tallest person, 193 centimeters, made one 2-pointer. However, another player, 160 centimeters, made two 2-pointers. This shows that height doesn't affect 2 pointers made. 2 pointers is within the performance criteria. However, only 9 players achieved them out of 18. This is only 50%. It shows that there is no significance as the P value is above 0.05. Figure 2 shows offensive rebounds and defensive rebounds. As you can see, there were 10 offensive rebounds and only 6 defensive rebounds, and there were 18 players. However, this is expected as not all of these players shown in the graph are experienced basketball players. As you can see, Alex and Jacob made most of the offensive rebounds. They made 3 each. Whereas Beth and George made none. This could be because of the position they were playing or where they were on the court at the time. Here there is more group data. Figure 2 shows how height of the player affects the offensive rebounds made. As you can see, for the line it's a positive correlation. The line is going up diagonally. This means the taller the player, the more likely you are to get offensive rebound. Therefore, in a game, the taller players will be at a slight advantage. The next graph shows how a player's height affects the amount of steals made. Once again, this is a positive correlation as the R value is a positive number. Once again, this means if you were a taller player in a game, you're more likely to steal the ball from your opponent and you have more of an advantage. Now I'm going to compare the difference between Aaron, an experienced basketball player, and Charlie, a non-experienced basketball player. Here's a movement schematic to show the two players' movement. It shows how each of the players moves around the court and uses the space of the court. However, it is easy to make mistakes when you are doing the movement schematic, because if you are doing it by hand and not by technology, so there may be some mistakes made as you're only looking at a computer screen and following where they're going on the court. Here you can see that Aaron makes more of a movement around the court than Charlie. This could be because Aaron's position is a point guard and he needs to be able to run around the court and pass and receive the ball from his teammates. Also, you can see that he runs in a straight line from one side of the court to another. This could be because he's shooting one side and then defending the other. Charlie is mainly on one side of the court. This could be because he's not an experienced player, therefore he's not used to the game and is not used to using the whole court. However, because he's a football player, he could be used to running up and down the wing and the edge of the pitch, and he won't necessarily use the whole pitch in one game. Comparison of the jump. From the first graph that shows an experienced and non-experienced player's jump height, I can see that the non-experienced player's jump height goes up with each type of jump. So at 45 was least, and 90 was middle, and CMJ jump was the highest. However, this is not the same with the experienced player, because the 90 degree was his worst. However, the CMJ was again his best. I can also see that they both jumped their highest on the CMJ jump. This could be because they're allowed to use their arms to propel them forward and propel them upwards. This could give them more power to push off. And also, they're allowed to be at any angle with their legs if they want. So they can go down and jump, whereas the 45 degree you have to start from that angle and jump up, and so you have to do the same with the 90. On the second graph, I can see that the non-experienced player has a higher propulsive impulse on every type of jump, and once again, this goes up with each type of jump. Whereas the experienced player, its biggest impulse was on the CMJ jump. Once again, its least impulse was on the 90 degree angle jump. This could be because it was his worst jump in the jump height. As you can see, the non-experienced on the 90 degree only got to 0.25 meters. From looking at this graph, and from both of these graphs, I can conclude that the 90-degree jump was the worst jump for the experienced player. This could have been due to other factors other than just having your legs at 90 degrees. And I see that the weakest jump for the non-experienced player was the 45-degree angle jump. This is because you have to get lower to the ground, and fatigue could start to set in if it takes a long time to measure out the 45-degree angle. Here I'm going to compare Aaron and Charlie's data between them, but also between the class. So I'll be able to see averages of the class, and I'll be able to see if they are above or below average. Charlie's jump height was higher than average, whereas Aaron's was below average. This may be because Charlie is taller, and therefore Aaron may have more muscle mass than Aaron. However, even though Aaron was shorter, he is heavier than Charlie. However, out of the group, they are both below average height of the group. Charlie's jump height could be more because he's still an athletic player because he plays football, and to play football you have to have a lot of muscle in your legs, so therefore this could help him with the power to push him up forward and get a higher jump height than Aaron. Aaron had a higher braking force than Charlie. The braking force is a force applied to the ground on landing. This may be because of the shoes he was wearing, or he may just come down heavier on the ground. However, it doesn't really apply much because it's more of the force taking off we want to show how high you're going to jump from it. That's the impulse. Charlie has a higher impulse than Aaron, as Charlie's was 188 and Aaron's was 174. This could be the force taking off could be higher for Charlie because he has more muscle in his legs. However, Aaron's an experienced basketball player, so he should be used to jumping. However, because his position is point guard and not power forward, he's not really used to shooting and jumping up high to get the ball. Charlie needs to be able to kick his ball in football, so therefore his muscle in his legs will probably be bigger than Aaron's. From his data, I can also see that Aaron had a higher mean power than Charlie. Aaron was shorter but heavier than Charlie. They both were above the group average of power. Charlie's jump height was higher than the average. The higher the impulse, the higher the jump. The lower the impulse, the lower the jump. Charlie is higher than Aaron. If they have more muscle, it can mean they have more power. Now I'm going to compare the players once again and compare their P and R value. Impulse and jump height have a positive correlation, as it's a positive R value, and it is significant because the P value is below 0.05. This could show that the bigger the impulse you have, the higher you'll be able to jump. Aaron's impulse was 174 and his jump height was 0.37 meters. However, on the other hand, Charlie's impulse was 188 and his jump height was 0.44 meters. From this you can see how the bigger the impulse, the higher the jump, as proven by our experienced and non-experienced player. Mass and mean power have a positive correlation, as to the positive R value, as it's not minus, and it's significant once again because the P value is below 0.05. However, mean power up and mean power down have a negative correlation, as it's a minus R value, and it has no significance as the P value is above 0.05, as it is 0.063. This is a diagram of the stretch short reflex. This diagram shows that when you're hitting a knee with stimulus, it sends an impulse to the spinal cord through the sensory neuron, where it reacts and sends an impulse through the motor neuron to the muscle, which then causes a reaction from your leg. Take two types of muscle contractions, the eccentric contraction, so this is when you lengthen, and the concentric contraction, so this is when your muscles shorten. For example, when you're squatting, your muscles are shortening, so you're in a concentric contraction. However, when you jump up, your muscles lengthen, and therefore they're in an eccentric contraction. These are helped by the muscle fibers. For another example is if you're doing a box out, your legs are in a concentric contraction. Once the muscles relax, the spindle fibers send an impulse to the nervous system to tell the muscles to contract. The faster this is done, the more force you can produce, meaning it results in a higher jump, as we can see by the 45-degree and the 90-degree angle jump. The CMJ has evidence that it's a better jump if you do it quicker, because the muscles can shorten and lengthen quicker, to do an eccentric and concentric contraction quicker. Now I'm moving on to the technical model, and I'm going to talk about the perfect model compared to our two players. That was Aaron's. And that was Charlie's. Now comparing Aaron's to the perfect model, we can see he keeps contact on the player, which is the first picture. He boxes him out, pivots and keeps low, which is shown by our second picture. He jumps for the ball, which is shown by our third picture. And he keeps his elbows up and secures the ball with both hands. It's important that you secure the ball with both hands and not just one, because the ball is more stable in your hands and you're less likely to have it stolen from you. It's good to keep contact from the player so that when you pivot, you have contact and you know where they are behind you. If you didn't have contact, you'd easily be able to lose them and they can run around you and take the ball from you. It's important that you jump for the ball instead of keeping low to the ground, because this ensures that your opponent doesn't get the ball before you do. Now, comparing it to Charlie's data compared to the perfect model, from the first photo you can see he keeps contact on the player. Second photo, he boxes him out, pivots, however he doesn't keep low, so this could be a problem for him. He doesn't jump for the ball, he keeps his elbows up and secures the ball with both hands. By not jumping for the ball, he's allowing his opponent to go round him and he could steal the ball, or his opponent could jump for the ball and take it from him. Once again, it's good that he's keeping contact on his opponent because he knows where he is behind him without looking. Also, it's good that he secures the ball with both hands, because then it's more secure in his hands and it's less likely to be stolen or knocked out of your hands. And to keep your elbows out keeps your opponent away.